All right, we're going to do a super fast overview of some SAT practice questions. So these are a little bit on the easier side for the most part. May or may not be stuff that we have covered before. So looking at these, you got a car rental company charges a flat fee of $25 plus $30 per mile driven. So flat fee is going to lead us to y-intercept, and per mile would be our slope. So that's a linear equation. Write the equation for the total cost after driving a number of m miles. So C is going to be 0.3 for the 30 cents times the number of miles plus the $25 flat fee. And it wants us to find the total cost if 120 miles are driven. So to do that, we would just do 120 times 0.3, which would give us 360, but move the decimal back once, it would be 36. So 36, and then we need to add 25 to that to get 61. And so you'd probably see it written as C of 120 equals $61 if they do it in function notation. Now number 2, solving for x here, no surprises there. Just adding 7 to both sides to get 20. So 4x equals 20, which means when we divide, x is going to equal 5. Next we have f of x equals 3x squared minus 2x plus 5. We want to find the value for f of 4, so we're just going to plug in 4 for x, which would give me 3 times 4 squared, which is 16, minus 2 times 4, which is 8, plus 5. And when I do 3 times 16, that's 48, minus 8 plus 5 would end up giving me f of 4 equals 45. Okay, on to the next one. We have a rectangle. Length is 3 meters more than twice whatever the width is, and the area is 44 meters squared. So the width is just going to be W. Length is going to be twice the width plus 3. And so in order to solve that one out, we know area is length times width, so we do width times 2W plus 3. That's going to equal 44. So I get 2W squared plus 3W equals 44. And then I'm going to move this 44 to the other side to get the quadratic all together on one side. So 2W squared plus 3W minus 44 equals 0. And so from here, to solve it, we could put it in the quadratic formula, or we could do some factoring. To factor, I'm going to move this a value over for a minute and multiply it by the 44 to get W squared plus 3W minus 88. Then when we factor it, we're looking for something that multiplies to get negative 88 and adds to get 3.
Good morning, Wiley Bulldogs. Happy Friday.
So looking at that, need something that multiplies to negative 88 and adds up to 3. So if I do 11 and negative 8, that'll fit for both of those. So 11, negative 8 would be my two factors that I'm using. So that would be, this splits up into W plus 11 times W minus 8. And what needs to happen here is, since I multiplied that 2 into that 4 to get the 88, I've got to divide these by 2. And what I get is, this one doesn't divide, so we move the 2 up front. Get 2w plus 11. This one does divide, so I get w minus 4. And that's going to be equal to 0. So when I'm finding the width, I'm just going to say, well, what does w equal for these? And to get 0 here, w on this one would be negative 11 over 2, or w equals a positive 4. And since we can't have a negative width, our width would equal 4 for that. So a little bit more extra steps there, but we can solve it out that way using our quadratics. Hey, solving for x here when this is equal to 0, well, if I get either portion of this equal to 0, it's going to be 0. So on this left side, x minus 3, if I set that equal to 0, x would have to equal positive 3, because 3 minus 3 is 0. On this one, x would equal negative 4, because negative 4 plus 4 is 0. That's the only step we've got to do there. Okay, we've got a function g of x equals 2 to the x power. And if g of 0 is 1, find g of 5. So anything to the 0 power is 1. So if I do g of 5 would equal 2 to the 5th power, we do 2 times 2 times 2 times 2 times 2, which is going to give me g of 5 equals, should be 32. Okay, and then next I've got, the table shows the number of hours studied and the corresponding test scores for 5 students. And it wants to know the line of best fit. Well, one of the things that you have on this is that you have Desmos. And so I don't think I can pull it up on here, but if I do, if I put this in Desmos and do, let's see, put it in my 55, 65, 70, 78, and 84, and then it gives you an option to do a linear regression there. And so calculate the line of best fit's approximate slope. Putting that in or doing it in stat edit, I get a slope of 7.1. Okay, so that gives me the line of best fit there if we're doing a linear function on that. And again, that is just typing it into Desmos. Okay, next on 8. 40% of students preferred online, 35% preferred in person. The rest had no preference. So if 200 were surveyed, how many had no preference? So 40 and 35 would give me 75%. So preferred, so online plus in-person equals 75%. Means 25% had no preference. So no preference would be 25%. And I just do 25% of 200, which would be 50. On number 9, I find the mean or the average and the median of this data set. To find the mean, I would need to add all these together, which would give me, let's see, 20, 30, 38, 39, 40. 40 divided by however many, 1, 2, 3, 4, 5. Which would give me 8. And the median is the middle, so the middle term is also 8. So either way, mean and median here would just be 8. All right, looking at the next stuff, already put some information down here for us. So when we're looking at x minus 2 times x plus 5, because we have roots at 2 and negative 5, I'll do the FOIL method, or you could do box to solve it out. The first terms would be x times x, which is x squared. And that, and outer would be x times 5, which would be 5x. And inner, and last. So then I got negative 2x and negative 10. Simplify that a little bit, and I get x squared plus 3x minus 10 is going to be my quadratic equation right there. Okay, simplifying this expression, we're just multiplying these two together. And so I've got the numbers all multiply together. 3 times 2 gives me 6. X squared times x to the third. When that happens, I add exponents to get x to the fifth. And y to the third, y to the 1/3. Well, I'll still add those. And so it'd be y to the 3 and 1/3. Or we just change it to y to the 10 over 3. Which we can still get as exponents. Solving for 5 to the x plus 1 power equals 125. Well, on this, if I put my exponent like this, 125 is equal to 5 to the third power. So then I can drop off the 5's, and it just says x plus 1 equals 3. So x would equal 2. For the triangle, you have right triangle lengths of 6 and 8. It's already a regular 6, 8, 10 is one of our regular right triangles, but you could do the a squared plus b squared equals c squared, and 36 plus 64 would be 100, square root of 100 would be 10. So anyway you cut it, hypotenuse would be 10. Okay, finding the mean, if you add a test score of 92 in, you'd need to multiply by 80, add 92 to that, and then divide it by 7. Should bump it up a little bit on that. I won't solve it out here right now just for time's sake. And on number 15, we have h of k of 2. Well, what I'm going to do is, for k, I'm just going to plug in a 2, which is a little easier for us to do than if it didn't give us numbers. So k of 2 would be 3 times 2 is 6, plus 1 would be 7. So if that equals 7, then I'm going to plug a 7 in for x here. So it's minus 14. 7 squared would be 49. And so 49 minus 14 would give me 35. So h of k of 2 would equal 35. And on a data set that has a standard deviation of 5, multiply each of the points times 3. What would be the new standard deviation? Well, the standard deviation is going to be proportional to the data set, and so if the data set gets 3 times bigger, standard deviation gets 3 times bigger, so that would be 15. Okay, so that's a quick overview of some algebra and statistical type problems from SAT, kind of on the easier end, probably easier to medium end.